Welcome to another development update video for Cubiquity for Unreal Engine 4, the voxel terrain and environment middleware layer that we've been working on here at Volumes of Fun. So it's been a while since the last video, but I've been working hard on all sorts of different things. First of all, as you can see in the screen in front of us, we've got a cubic coloured cube style terrain working now. But a lot of the work that's really been going on has been at the low levels. During the last video, what I showed you was pretty much a vertical slice of what I'd got working at the time. So it was the minimum amount of code and so on that I could get to get the smooth terrain displaying and working inside the Unreal Engine editor. But now I've also integrated the colored cubes terrain, as you can see. And so to get both of the two different types of terrains working, I've done a lot of work in the underlying layers, trying to make the code as generic as possible and adaptable to any future feature additions I might like to make. So I'm going to jump into the play in editor mode and show you how the colored cubes terrain works. So you saw there probably briefly, as I loaded that, the sections of the terrain appeared chunk by chunk, and this is a small demonstration of the level of detail work that we've been doing in Cubiquity. So the terrain itself is broken into a small number of chunks, and depending on distance, further away chunks will be rendered at a lower resolution, meaning less triangles, meaning potentially faster frame rates for further away details when you don't need quite as much detail. So we can run around the terrain. You can see there's a small amount of popping in the background due to the relatively low level of detail threshold we've set for this demonstration. But you can see the colored cubes terrain is working. It's correctly loading the color for each of the different cubes. We've also applied some shaders and so on to the cubes just to make them look a little bit better than being plain colors. So that's how the demonstration map looks for the most part. So I'm going to now go through some of the code that we have, which we can use to edit the terrain and do all sorts of interesting things to manipulate it. So inside the blueprints folder, I prepared already a projectile. So this is a projectile which will be fired by the gun being held by the first person player controller when I click the middle mouse button. So if we go all the way to the left hand side, you'll see what happens when we fire this ball. So when the ball is fired, it will shoot in an arc, and upon hitting an object, it will check to see what the object is, and then we're going to try and create an explosion and make things look pretty like that. So first thing we do, we find the place where the ball hit, and we destroy the ball, and in its place we spawn a small explosion visualization just to make it look like there was an explosion happened. And the explosion size is used to scale up the size of that explosion to make the explosion size match what we're seeing. And for these demonstrations, the explosion size is set to 3, but of course we can scale this up and down, and we can make small explosions or large explosions. So that's just a visual effect while we're moving the ball to give the effect of an explosion. The next thing that we do is we take the location, or the object that the ball hit against, and then we check to see if it was one of our coloured cubes volumes that we have in Cubiquity. And if it was, then we're going to carry on and we're going to edit the terrain and remove those set of voxels and make it look like an explosion happened. If it wasn't one of our coloured cubes volumes, then we're going to ignore the event and we're just going to carry on. So if it was, we get the roll position of the event. So back over here, the hit location is in world space. So we convert that world space position into volume space position so that everything we can do is in the voxel positions within the volume itself. So given the location that the ball hit, we are going to loop over a 3D cube, an array of voxels centered around that hit location, of size explosion size once more. So it's going to be 3 in every direction, so a 9 by 9 by 9 cube we're going to scan over. And for each of the voxels inside that cube, we're going to check to see if the distance between the hit location of the projectile against the terrain is less than the explosion size, to see if it's within a sphere of the explosion. If it is within that sphere, then we are going to remove the voxel, and in its place we are going to spawn a single physics Unreal Engine style cube that's going to bounce around the terrain as you'd expect. And for each of those cubes, we are going to provide a small impulse to it of size explosion force, which again is a variable we can tweak, and the direction of that force is going to be in the radial direction from the center of the explosion towards where the cube is. So every single cube, once it be spawned, will be provided with an impulse away from the center of the explosion, so they will spread out as you'd expect. So all we're really doing in here is making the picture of the explosion, if you will, and then we're getting the volume that the ray hit against, looping over all the nearby voxels, and for each of those voxels we are replacing the voxel itself with an unreal cube, which is going to have physics applied to it, and it will bounce around the terrain. So a lot of the real magic here, as far as Cubiquity is concerned, is happening inside this remove and spawn cube function, which we are now going to move over and look at. So this is a blueprint function which I have implemented on the Cubiquity colored cubes object inside the editor. So this is built on top of the standard Cubiquity API. And all it takes is the local position. So this is the 3D position of the voxel you want to adapt inside the volume. So the first thing we do is we set the cube to be empty. And we do this first of all using the getVoxel function provided by Cubiquity. So this returns, given a position, the color of a cube at that particular, a color of a voxel at that particular position. So we convert the return value into a color, we look at its alpha value, which we are using to represent density, and the density is used at a certain threshold, in our case 0.5, to say whether that voxel is being displayed on the screen or whether it isn't. So if the voxel is more than 0.5 density value, i.e. it's being displayed, then we are going to do something with it, we're going to remove it. If it's any less than 0.5, it's already missing, so we're going to do nothing. So if we are going to remove it, we want to use the setVoxel function, and we set the voxel to have a value of red, green and blue of 0. Doesn't really matter what they're going to be, but most importantly, the alpha value we are setting to be 0. So the alpha value is less than 0.5, less than our threshold, so it's going to be not displayed on screen, so the voxel is going to appear to vanish. And that those parameters are then passed to the setVoxel function, both the color and the local position. So our voxel has now been removed from the scene, and we just want to replace it with a physics cube. So we basically grab the position, we convert it from volume position to world position, we pass that transformation into a standard Unreal Engine spawn actor, scaling it up by a certain factor to make sure the size of the cube matches the visual size of the terrain, voxel terrain object we're working with. We then set a random lifespan so they don't all the cubes in the explosion don't disappear at the same time, and then we pass the returned cube object back to the previous function, the calling function, which in our case was this projectile, and that's how we then provide the impulse to it. So you can see all that magic there is literally just removing a voxel and spawning a cube in its place and providing it with a semi-random lifetime. So we'll show how this looks in game. So if we press play once more, volume loads up, and so I can click the middle mouse button, it will fire a projectile like that, but if it hits the terrain, an explosion happens, and for every voxel within a 3 cube radius is removed and replaced by a black cube which is interacting with the terrain in a real physics way. So you can see they're flying off of the place, bouncing around the terrain, and we can do this with a number of different positions and it will all work as you'd expect. We can even make holes in the floor and the cubes correctly fall through, and you can see that it's affecting the terrain as you'd expect, and we're falling down into the newly created hole. We can even burrow most of the way through and you can see the cubes falling away to their doom through the ground. So you can see that the terrain is being correctly affected by everything. We can vary the size of the explosion and it will automatically make things happen larger and smaller as you'd expect. So this is only a very small map to demonstrate this on. So now I'm going to disappear off for a moment, load up a new larger map, and we're going to run around there and I'm going to show off some explosion on a much larger scale. So I'll be back in just a moment. And welcome back. So I've now gone away and loaded up the much larger city map. So this is a fan-made map for the game Ace of Spades Classic from the buildandshoot.com forums. and the author of this map very kindly has allowed us in Cubiquity to provide this as a demonstration map to show off large map loading capabilities of the engine. So this is a large map, it's the largest map that we've tested with so far, built out of individual voxels, and every single one of those voxels is removable. So using the same script as I showed in the last video, we can fire our projectiles, and when they hit things they are going to explode, and as before they're going to cause cubes to fly out. So we can shoot over large distances and provide and cause massive destruction across the whole map. Everything in this map, as I say, is destructible, so we can cause holes to appear in anything, we can burrow into buildings, we can cause anything in this map to be destroyed. So I'm just going to run around a little here and make some holes in things, because I think this is the most fun I've had with Cubiquity, is running around blowing things up. So you can see that this map I have caused the scale that the volume is being rendered at to be twice as large as the last one. So each of the voxels is now about a meter cubed rather than being 50 centimeters cubed like they were in the last video I showed, and that's just a simple scaling in the Unreal Engine editor to do, and due to the way the scripts were written to cause the explosions, that scaling factor is automatically incorporated, and so the cubes that are being spawned in place of the voxels are appropriately the right size. So everything is matching up as it should. So as you can see, this map really is very large. You could spend, all day running around here blowing stuff up, and you probably still wouldn't have destroyed every single voxel. So hopefully that gives a sense of the sort of scale of maps that Cubiquity can currently support. As we're going into the future, we're currently working on allowing much larger maps to be supported. So hopefully in the future we'll have infinite maps being paged in as and when they're needed, perhaps being generated procedurally, and allowing you to create whole worlds out of volumes from within Unreal Engine. So, thanks for watching. I've been Matt Williams from Volumes of Fun. Please do subscribe to our YouTube channel, and we are also found on Twitter and Facebook and Google+. For further updates, the best place to follow is the forum post on the Unreal Engine's forum. There will be links for all of these in the comments of this YouTube video. So, thanks for listening, and hopefully see you again soon.